Hello guys, welcome to the YouTube channel for COVID Chemistry. This channel will take you through all of the GCSE content required for the chemistry course, mainly across international AQA, but incorporating many aspects of Edexcel and Cambridge also. The way in which these lessons are going to work is you will have a template in which you are required to follow on the board. It'll be very methodical, we'll work slowly, we'll get our definitions, we'll put all of our work into a practical setting, and we will work slowly with this. So what I would like you to do, and this is going to happen with every lesson, I have our template on the board. We are going to work through all of the sections together. So what I would like to do is pause the video, copy the template from the board into your journal or your planner or your science book, and I'm going to jump out the video now. You can pause it and then we will begin. Okay, so let's get going. The lesson we are going to look at today is chapter 1 of the GCSE chemistry course. It is a nice introduction and it incorporates a lot of information from your key stage 3 chemistry knowledge. We are going to be looking at states of matter, which we'll know from your key stage 3 course, but the extension work we want to incorporate for GCSE is how we can use this knowledge for our changing states graph. We're then going to look at our first required practical that you'll have to do in relation to diffusion. Because we're learning online here, I will have a link in the subscription, or in the description part, should I say, of this video to the required practical videos. We then need to look at a few definitions and then look at the atomic structure and the subatomic particles that make up a variety of atoms. We're going to identify the charges of these, the masses, and then you'll be introduced to a new term, and we're going to define what we mean by an isotope. Okay, so I hope you're ready to go. Our 3 states of matter that we're going to look at, nice and basic that we'll know so far. We're going to identify the particle arrangement in a solid, the particle arrangement in a liquid, and finally the particle arrangement in a gas. Okay, this is something that you might need. Yes, I know this already, but we are going to take this information and move to the next level within our chemistry knowledge. So I would still recommend making the notes from here, because it looks well in your GCSE revision notes when you are revising for the big exam. Okay, so our particle arrangements within our solid. Yes, it's nice and simple. We have this regular arrangement of these particles. They are packed extremely close together. Please excuse my drawing, I'm not the best artist here. So we can see this regular arrangement of our particles. And the key word we want to use within the particle arrangement of our solid is that these particles, what can they do? So these particles, they can vibrate within their position. As you can see, there is not much movement that is allowed to happen. So they are vibrating within this regular pattern, nice and simple. From our solid, which was number 1 next to our liquid, okay, within our liquid, our particles, they are a little bit more free to move like. Let's put another one in here. So the key term we want to be able to relate to the particles within a liquid. Nice key term. We state that these particles, they can, what we say, slip and slide between each other. So we have vibrate, slip and slide. We can see how we're changing the way in which these particles are arranged. So nice and easy, solid, liquid, and finally we are going to look at our gas here. So our gas, okay, so our particles, what can they do? They can move. They can move freely Key term now, in, all, I'm running out of space, directions, nice and simple there. So for our gas and particles, they can move freely in all directions. And a key reference we want to make about the particles which make up a gas is that they can fill the container in which they are placed within. So now, nice and easy, we can compare and contrast the particle arrangement within 3 different states of matter, and the key words we want to be able to relate to this. Solids, they're just vibrating on the spot, regular arrangement, not much movement. Liquid particles, they can slip and slide between each other. And our gas particles, they are free to move in all directions, and they can fill the container in which they are enclosed within. Alrighty then, so let's keep going. That was nice and easy. That'll just be a refresher of your key stage 3 knowledge. Now, what do we need to know for a GCSE course incorporating this information? We need to refer this knowledge to a graph which is very popular within all GCSE examination questions. And we call it our changing states graph, okay? So with every graph, you have your x-axis and you have your y-axis. So first, I hope you have your graph ready to label. We are going to put our time across the bottom, and we are going to put temperature on the y-axis. Let's label our axes, let's get into good habits. So we have our x-axis and we have our y-axis going up like that. So the changing states, this is going to incorporate the 3 states of matter we have just looked at with our solid, our liquid, and our gas, and it's going to continue within this pattern, solid, liquid, and gas. So we have a situation where our graph is going to look like this. Okay, so what is actually happening within this situation, and how can we incorporate this knowledge here? So we can add some information into here. I'm going to put point A, point B, and point C. And we are going to state what is happening with these here. So at point A, we want to be able to identify on our changing states graph that our solid is melting. Key term there. So we can see here, as we increase temperature, or time is increasing, temperature is increasing, our solid is melting. An increase in temperature, solid is melting. Okay, that's nice and easy. That's going to then disrupt the particle arrangement that makes up a solid. We have these key areas in here. We have this flat line where we state that we are having a plateau. There is not much taking place here in this flat line. The particles, they are just rearranging, they are changing their state, okay? Then we get to point B, increase in temperature or increase in thermal energy, nice key term there, applied to our solid. We are going to be changing state to a liquid, okay? So next, we can identify that our liquid is boiling, okay? So there we've gone from our solid to our liquid. We then have the same situation taking place. We're changing the arrangement of these particles when more thermal energy is added. And you guessed it, yes, we've gone from solid, we've gone from a liquid, and now we've gone into a gaseous state. So we have a gas. What key term can we relate to that? Well, we can say our gas is vaporizing. So nice and simple there. We can see an increase in temperature over time is changing the state of a solid, a liquid, and a gas. So nice and simple. Temperature Sometimes, mostly we'll see referred to in degrees Celsius. Anyone want to do some advanced work, you might see it in a unit called Kelvin, and we have 298 Kelvin is the equivalent to 25 degrees Celsius. Some nice advanced work there for people coming to the end of their GCSE course and who will be going on to study the A-level chemistry course. Nice and simple so far then. Solid, vibrating, other particle vibrating. Liquid particles, they are slipping and sliding, and our gas, our particles are free to move in all directions. And our gases, they can fill the container in which they're enclosed within. Changing states graph, increasing temperature is going to change our state. We can kind of visualize this, can't we? So if we think about a solid block of ice, we're adding thermal energy. The more thermal energy, the more heat we add over time, we're going to have our solid block of ice melting, nice and simple, into water. Then we're having this boiling of this water, changing into a gas, this vaporizing, and this water vapor produce a nice visual for you to understand this concept here. Okay, chapter 1, let's continue then. So, chapter 1, we now want to be able to define what we mean by this term diffusion. Okay, for some people, you might remember this, but please make a note. So, diffusion is the movement of, key term, we're referring to these particles again. The movement of particles. They are moving, where are they moving from and where are they moving to? They are moving from an area of what we call high concentration to an area of low concentration. So what do we mean by this? Okay, so picture this. You're at home, your mother or your father is walking around, they have the nice can of air freshener spraying around your bedroom or spraying around your living room. Within this can, we have a high concentration of these gas particles. They're all squashed together, they are enclosed within this small space. When you spray this air freshener, we're going to have this diffusion taking place from our can, which is the high concentration, traveling through the air to this low concentration traveling across. Okay, so you can probably picture this. Someone in your house sprays this air freshener, you're stood 10 meters away, eventually you are going to be able to smell this. It's the same within a department store, within a shopping mall. You go in the shopping mall or the duty free at an airport, you spray some nice smelling perfume or some nice spraying aftershave, it's free, we all do it. You spray it, eventually someone in the distance, maybe 5 meters away, they will start to smell that as well. So this is the process of diffusion. A highly concentrated area within a cylinder or a can for our gas, we're spraying, these particles are diffusing away to our low concentrated area. So there we go, diffusion. Okay, so 2 practicals that you probably will do. One required practical, and another one is looking at diffusion in liquids. It's very, very simple. You might be able to do this at home if you have some food colouring. So in the classroom, you would take a glass beaker. What you will do, you'll get some food colouring, this highly concentrated bottle, and you will put it into the liquid here, and you will watch this diffusion taking place. You will see how these particles, they are travelling through the liquid and they are spreading out as time moves on. Okay, I'm going to put a link to one of them videos in the description below. It's very nice to see, it's a nice visual to understand this diffusion situation. Your required practical that you will definitely do in class is involving ammonia solution and hydrochloric acid. Your teacher will take 2 cotton wool balls. They will soak 1 cotton wool ball in highly concentrated ammonia solution and 1 cotton wool ball in highly concentrated hydrochloric acid. They will place it in 2 enclosed cylinders and join them apart. and you will see gases traveling across these cylinders, okay? Once again, similar to the diffusion in liquids, I'm going to put a link to a really nice video. There's lots of good stuff on YouTube under my video here within the description, so you can click that link and you can see this required practical. Just for your peace of mind though, the diffusion that we want to be looking at through gases within this required practical is this equation here to produce our ammonium chloride. If you want to refer to this and do some further reading, which I would recommend, in your IGCSE chemistry book that I've emailed you yesterday, please have a look at page 7. This has a great description and some great illustrations to talk through this. Lots of information so far. So recap. Particles, 3 states of matter: solid, liquid and gas. Solids vibrating, liquids slipping and sliding, gases free to move. We then looked at changing states graph. As time is increasing, we're adding more thermal energy, temperature is increasing, how we can change through these 3 states of matter. Then we got a little bit more difficult. We defined this process of diffusion, the movement of particles from there with high concentration to low concentration. The best way to visualize it, like I say, your air freshener. If you're in the classroom, you're at one end, you spray it, your friend will eventually smell it at the other end. Diffusion through a gas, looking at your required practical, your ammonia solution and your hydrochloric acid in your cotton wool balls. Alright, shall we continue then? 3 definitions we want to be able to state. We want to be able to define what we mean by atoms, what we mean by elements, and what we mean by compounds. I'm right-handed, so I'm going to have to flip the other way. I can't go right the other way. So are we ready for some definitions? So atoms, what are they? We refer to them as being the smallest units, I'm reaching here, of matter. Okay, it's the smallest unit of matter. Let's put some more information in. They are made up of 3 subatomic particles. Can you think of them before I write them in? Okay, hopefully you got them there. They're made up of protons, electrons, and our final one, neutrons. Oh, I'm struggling for space, but we got it in there. So our first one, atoms, they are our smallest unit of matter, and they're made of protons, neutrons, and electrons. All right, elements. Next definition. We say it is a pure substance consisting of one type of atom. What a nice definition. I get that question in your GCSE exam. Just recite this definition here. Wow, really good answer. Elements, we find them in the periodic table. Periodic table of elements. Okay, and finally compounds. What are they? They are 2 different, very key term here, 2 different elements joined. Oh, I'm just going to put TOG for together. I do apologise. So 2 different key terms. Can you think of any example? 2 different elements chemically joined together. Plants use it in photosynthesis. We breathe it out. Okay, so nice. Carbon dioxide, 2 different elements. Carbon and 2 oxygens. Oh, lots of what's in. Let's keep going. I'll have a little drink of my Starbucks. This is not a paid promotion, by the way. Starbucks, if you do want to start providing free drinks for me in this video, feel free to do so. Alright, where are we we're up to subatomic particles, nice and simple. We've mentioned these already, so we have our protons, we have our neutrons, we have our electrons. Alright. Two pieces of information we need to be able to state in relation to our subatomic particles. We want to talk about the relative charge and the relative mass of these. So the relative charge of our protons, nice key information, P positive, they are positively charged. So we say we have a +1 relative charge. Neutrons, they have no charge or a neutral charge. The relative charge is 0. Electrons, relative charge, okay? So protons, positive, neutral. We'll have to balance all of this out, so we have a negative charge like this, okay? That's that information. Let's have a look at the mass and the relative mass of our protons, our neutrons, and our electrons. This is something that we just need to remember. Please make a note of this. We have a relative mass of 1, neutrons 1, and we say for our electrons that the relative mass is very small. Oh, I hope you're still with me, guys. Okay. So, let's keep going then. Atoms, elements, compounds, subatomic particles, relative charge, relative mass. I've given an example here. If you have your periodic table in front of you, please get it out and please find lithium within your periodic table. You will see that we have Li, it's a chemical symbol. Every element within the periodic table is abbreviated, okay? It has 1 letter or 2 letters. Don't just presume that every element is just a shortened version of its full name. So lithium, L-I-T-H-I-U-M, shortened to Li. We have some variations here, potassium being K. Okay, so make sure you are aware of the sodium Na. So we're not always following this pattern. You can see we have two numbers here. We have what we call the atomic number. We also have the atomic mass. So the atomic number, it tells us the number of protons and the number of electrons. We also need to be able to find out the number of neutrons, and we can do that nice and simply. We can subtract our big number from our small number, our atomic mass from our atomic number, okay? So let's just work through an example. We want to be able to draw the atomic structure. So an atom, smallest unit of matter, made of protons, electrons, and neutrons. Let's demonstrate what we mean by this. So in every atom like this, we have a nucleus in the center. I'm going to put my chemical symbol. Within our nucleus, we have living our protons and we have our neutrons. First, I'm going to identify the number of protons that we have within our nucleus. For our protons, we're going to look at our atomic number here. So protons, we have 3. I apologise for my formatting, I've not given myself a lot of room there. We said that our number of electrons is equal to our number of protons. So the electrons, they live on the outside like this. But we need to follow a rule within GCSE chemistry. Here we have our first shell. And within our first shell, we can have 2 electrons. Within our second shell, we can have 8 electrons. Within our third shell, we can have 8 electrons. And then in our fourth shell, we can have everything else. Okay, so let's use that information to identify where we can place our 3 electrons. So we're going to put 2 on the first shell. That's the maximum we can do there, so we're happy there. In our second shell, we can put a maximum of 8. How many more do we need though? 1, 2, 1 more, because we need 3. and simple. Number of neutrons living in our nucleus though, we can subtract what we call here, we call it our atomic mass. And small number, we have our atomic number, okay? And in order to find our neutrons, we do our atomic mass minus our atomic number. 7 minus 3, we don't need our calculator for this, is 4. So neutrons equals 4. I hope you may have realised then that we can identify that the atomic mass 7 represents the number of protons and neutrons within the nucleus. Okay, great work there. A bit of an extension here, choose any element, a nice simple one, choose some low numbers here, maybe have a look at helium, maybe have a look at potassium, and practice writing out your atomic structure. Okay, a final thing we want to go to is our isotopes. So isotopes are a very, very interesting concept within chemistry. We can say that every, or not every element, certain elements exist as having a different atomic mass, okay? So we can say an isotope is an element that has the same key term, same number of protons, but different testing myself here, different number of neutrons. Very, very important definition we want to be able to state for our GCSE chemistry course. There's some extension work for you to complete in terms of isotopes. So I'm going to give you an example of a very, very popular one. Carbon is a popular isotope. So we have carbon 12 and we also have carbon 14, like this. So same number of protons, but a different number of neutrons. Kind of a tricky topic. I'd recommend doing a little bit more reading. In the GCSE chemistry book, there is some further information about these isotopes. Okay, so there is our introduction to the GCSE chemistry chapter 1 course. I hope you have managed to follow this template on the board. What I'm going to do, I'm just going to jump out again so you can pause it. Maybe there was something you couldn't see behind me that I was blocking, so I'm going to jump out now. Okay, so thank you for watching. Please tune in, and we are going to be working through chapter 1, chapter 2, chapter 3, all the way through the course. We're working methodically. Make sure you do your homework, make sure you have a look at page 7, have a look at our required practical course, and make sure you click the links in the description below to look at this diffusion in liquids and a diffusion in gas. Thank you guys.